Hello. I just had a word with a few children of class 11 and I got to know that the principle of mathematical induction is a topic which is actually troubling you, especially if we talk about the sums on inequalities. So that's why here I am with a lecture on the principle of mathematical induction, which primarily is going to be focused on proving inequalities. So make sure first, when I discuss about the principle of mathematical induction, then when I tell you the steps, and then after that we'll first be doing a sum on proving a equation, and after that we will be looking up how to prove an inequality, again by using the principle of mathematical induction, is what you should watch very sincerely and with apt attention, and I can assure you that you will be able to understand all of this with a very good rationality, and in times to come when you apply these concepts that I tell you, you'll be able to do these sums with ease. So all the children, are you ready? Yeah, right. So at this time you should be seated on a table and chair. You shouldn't be having any writing material. You should be sitting at a secluded place and shouldn't be having any other disturbances like your mobile, television, laptop, etc. Keep them aside, and at this moment just focus here, and I can vouch that now you'll be able to understand this like never before. So let's get started, children. The first thing that I'd like to tell you people is, when we talk about this, the principle of mathematical induction, it actually tries to prove some mathematical statement. Now a mathematical statement is a formula or is an identity. That means it's an equation which is true for every value of the variable. For that matter, if say we talk about sigma n, then sigma n is equal to n times of n plus 1 divided by 2. Now sigma n means what? It is when the value of n varies from 1 to n. If you add the numbers like 1 plus, again adding 1 to it, that is 2, again adding 1 to it, that is plus 3, and all of this goes up to n terms, then the sum of it is n times of n plus 1 upon 2. So this equation always will stand to be true for any value of n, and that is why it is known as an identity, right? So now children, we'll be looking up the steps which we actually use in the principle of mathematical induction to prove such an equality, right? And after that, obviously we will be turning our attention towards proving of inequalities. Now children, we first talk about the first step, and it is, we talk about the statement P when we have taken the variable to be 1. So P1 represents the mathematical statement that we want to prove if suppose there was just one term. So how is it going to give a result which is actually true on either side of the equation? So here when we talk about P1, obviously you will now be talking about the left hand side to be, in place of n, 1 kept, so that will be 1 times of 1 plus 1, right? And it is going to be divided by 2. Now if we talk about the right hand side, we actually just to take up one term, right? That is 1. So now if we are able to prove that the left hand side also comes to 1, we can say that the statement P1 is true, right? So here we have 1 which is going to be multiplied with 1 plus 1, which is 2, and it is divided by 2. As such, 2 gets cancelled, and thus we get 1 which is equal to 1, and therefore you can say that if you talk about P1, it is true. So this is the completion of the first step. Now we come over to the second step, right? The second step is actually one such which is going to make you very happy, because we are going to assume something to be true without doing anything about it. So this is what we do in the second step. That is, now we are going to take this assumption that let the statement P, where in place of n we have m, right? Remember that m is what? M is from the set of natural numbers, as if you talk about n is also from the set of natural numbers, right? And then what happens is you will find that Pm is true, which is what the assumption is. Just give me a second. Okay, so now children, after this we now talk about the statement where n will become equal to m. That means if we talk about the side which is one which has many variables which are to be added, then obviously it's going to be like 1 plus 2 plus 3 plus and so on. Now in place of it going up to n terms, it is now going to go up to m terms because we are replacing n by m. So all of this goes up to m terms, and the sum of all of this should be equal to, in place of n now again m, and in place of n plus 1 we'll now have m plus 1, and that is going to be divided by 2. This is what we have to now consider to be true, right? Very simple, isn't it? So doing the first step is pretty simple, just by keeping the value of n to be 1 and seeing that both the sides of the equation is true. Now if you get to see that P1 is not coming to be true, that means you have actually picked up such a statement which is not a identity. For that matter, then you can't prove that equation to be an identity by using the principle of mathematical induction, right? So if the first step is proved, then you come over to the second step, which is known as the induction step, right? What is this step known as? This step is known as the induction step. So if you consider in place of n m, and whatever statement P has been given to you, if you consider that to be true, right, and then what do we have is we will now have the induction step. Now after this we have the third step, which is actually the proving step, right? So next now we come over to the proving step, and now we talk about proving step. Okay, now in the proving step, children, we have to prove that 1 plus 2 plus 3 and all of this goes on, right, up to the mth term that we just looked up, and to that we are going to add one more term, that is m plus 1, right? And now we, on the right hand side, in place of m we will be keeping m plus 1. As such, we will have m plus 1 in place of m, and in place of m plus 1 we will actually have m plus 1, to which 1 also has to be further added, and all of this is divided by 2. So next now, children, what we do is, as we see that this is a statement which actually represents Pm plus 1, so further we can say that this is actually the step which is to prove the statement P, where in place of n for the variable we have m plus 1 to be the variable, right? So this is what the third step is. Now what we do is we now talk about the first m terms, right? As you know, the sum of the first m terms has already been taken to be true, right, in the last step to make things easy, and its value is how much? It is m times of m plus 1 upon 2, and that now is what we are going to substitute. So now we'll be having m times of m plus 1, right, which is further divided by 2. That is the value of the left hand side, which is the statement that we've already considered to be true. Now to this is added m plus 1, right? And on the right hand side, now as we are talking about keeping in place of n m, that's why we have replaced m with m plus 1 wherever it was. So obviously now the right hand side becomes equal to m plus 1, with which is multiplied m plus 1 plus 1, that is m plus 2, right, and it is divided by 2. Now children, here in the left hand side we find that there are two terms, and both of these terms are such that one is a fraction and the other is not. As such, what you require to do is you require to take an LCM and solve out the fractions. But there is something more that requires to be done. Yes, Arihant, can you tell me this? Yes? No? Well, I'll tell you. You find that there is something which is common. So as such, what we do is we will take this common entirety, that is m plus 1, outside, and now inside we'll be left out with m upon 2, to which now we'll be adding 1, as m plus 1 has already been taken outside. Now if we talk about the right hand side, it still remains to be m plus 1, which is multiplied with m plus 2, and it is divided by 2. Now for the children here, we will be having m plus 1, which is now going to be multiplied with m plus 2 and to be divided by 2. Now let's try matching. If we talk about the left hand side, it is m plus 1 times m plus 2 divided by 2, and the right hand side is also exactly the same, that is m plus 1 times of m plus 2 divided by 2, right? So both the sides being equal, you can now say that therefore p m plus 1 is true. And now comes a very essential statement. Now what is that very essential statement? This is what you require to write at the end of every sum proven by the principle of mathematical induction, and that is this, that you will say now that for every m plus 1, rather m to be an element of natural numbers, m plus 1 is also an element of natural numbers, right? And since this had to be proved for n, which is also from the set of natural numbers, so you will say that, and since n is an element of natural numbers, therefore we will say that p m plus 1, and thus we have Pn to be always true, right? So this is a statement which you require to write at the end of every sum which has been proved by the principle of mathematical induction. I'm sure there must be certain points where you must be feeling that if sir would have explained again, then probably we would have benefited. I know that I can hear you out, right? So what I'll do is I will actually repeat all of this concept so that this becomes extremely clear to you people, rather crystal clear. Okay, so here we are trying to prove a mathematical statement, or in other words an identity, by the principle of mathematical induction. Now this actually contains 3 steps. The first step is the step of unity, where on the left hand side, where normally the terms are, you will pick up one term, and on the right hand side, where we have an expression in place of n, we will actually be substituting just 1, right? And thus here we will get 1 to be on one side, that is the first term, and on the other side, which actually has the expression, will be in place of n1, so 1 times of 1 plus 1, which is 2, and it is divided by 2. So obviously this becomes 1 into 2 divided by 2. Now 2 and 2 will get cancelled, as such you will get 1, which will become equal to 1, and therefore you can say that p1 is true, right? So p actually is the statement and 1 is the number for which it is true, or it is the value of the variable for which this statement is true, right? So this, children, is the first step. Now after this we talk about the second step, which is really simple, and I'm sure you people are enjoying the company of this step. The second step is known as the induction step, and it tells you that there be a statement p, and for a variable m, where m again is from the set of natural numbers, as remember, which was the requisite for this sum, right? That is n be from the set of natural numbers. If not written, I'll rather write it, that here we have n to be an element of natural numbers. So with this as a stipulation, we now have 1 plus 2 plus 3 and so on. This goes up to m, and the sum of all of this is equal to m times m plus 1 divided by 2, right? Next now, children, if we talk about the third step, right, this is, remember, something which has been considered to be true, right? So let pm be true. So thus you can say that this statement that we just wrote is actually what is something which can be considered to be true. So we will say that this is true, right? Now, children, after this we now talk about the next thing, that is the most important step in proving a sum on principle of mathematical induction by proving the statement which is pm plus 1. So here, children, this step is known as the proving step, and here actually we try to prove that the statement pm plus 1 is true. Now for that we take the help of the last statement, that is pm. So now first we write what pm plus 1 is going to be, and that will be, we start off from the first term of the series, that is 1, to that we add 2, to that we add the next one, that is 3, and so on we go up to the mth term, right? That is m. Now as we are trying to prove Pm plus 1, so in place of m now, we also have to substitute m plus 1. As such, the next term becomes equal to m plus 1. Now on the right hand side, as the expression was m times m plus 1 upon 2, so here we are going to have it as m plus 1 in place of m times of m plus 1 plus 1 divided by 2. Now when you solve this, this is going to become equal to m plus 1, which is multiplied with m plus 2, and it is divided by 2. Now further here, what you will do is you get to see that on the left hand side you actually have something which you already proved to be true, that is 1 plus 2 plus 3, and all of that continues up to m, and the value of all of this is m times m plus 1 upon 2, and that is what we'll write here. To that now m plus 1 is added, which is still left out. Now as you see that there is a sum of two fractions, so you require to take an LCM, but before that you get to see that there is a term which can be taken common outside, which is actually a binomial. In the first term it's a term, right, and the second term it's actually a binomial till the time we don't put up a bracket, right? So m plus 1 can be taken common outside, inside then we'll be left out with m upon 2 plus 1. Now next, if you take an LCM, it is going to be 2, and then you will have this m plus 1 which is already outside multiplied with m plus 2 divided by 2. Now here further we have this, and if you look up what is there on the right hand side, we actually already had this, that is m plus 1 times m plus 2 upon 2, right? Thus the left hand side becomes equal to the right hand side, and therefore we can say that Pm plus 1 is true. Now comes the statement which is quintessential for every sum in the principle of mathematical induction. We say this, that is for every. Do remember that this actually represents a sign in mathematics which stands for every, right? So for every m, now this sign which almost looks like E or epsilon in physics, right, is actually what is element of. Okay, so here we have for every m, which is an element of capital N. Capital N is a set of natural numbers. M plus 1 will also be an element of natural numbers, right? Now since n is to be an element of natural numbers, that is why we are talking about m and also m plus 1 to be from the set of natural numbers. Now next we say that Pm plus 1 and thus Pn to be always true. Here we have Pm plus 1 which has come to be true, and again, as if you talk about n, it will be from the set of natural numbers, thus for that also this is going to come to be true. So this is how we do a sum by the principle of mathematical induction if it is an algebraic identity or probably a series which is going to be true for any value of the variable. However, when we are to prove inequalities, then the concept varies, right? We try and do something which is a little different in every sum, and then we try and prove what the inequality is. But there are certain common things, certain tips and techniques which I'll tell you, with the help of which you will be able to deal with the inequalities in a very easy way. So let's look up a question which is actually in inequalities, right? So this is a question that I have for you people. First, I'll give you people a little time for trial, and I like you people to try it out, and after that then I'll be discussing the sum with you people. Moreover, here I'll just be able to give you 10 seconds. You should pause this for a longer duration of time, right? And then you should also try it similarly for a longer duration of time. As the concept is clear, you just have to apply your logic. And when you keep applying your logic again and again, even if it is a very difficult sum, there'll be a time when you'll be able to solve the most difficult sums, right? So keep trying, right? So thinking that you people have all tried out, right, and you have come to a result, which please write in comments as to what result you came to, how much you were able to do, so that I can really assess how you're doing in mathematics. Moreover, do remember that there are a lot of resources that I have which I want to share with you and help you out in your journey of mathematics, from just studying the subject to tomorrow employing yourself again with the help of mathematics. Somehow or the other, some logic is required, and that you will draw from mathematics to be in very good employment. where either you're seeking employment or you will be providing employment, or in other words, you will be doing some business. Everywhere, remember, logic is required, and mathematics is what teaches you logic. For an example, I can tell you, I myself have developed a lot of logic after studying mathematics in detail. Right? So, in times to come, I'll be discussing my story. Right? So, if you have a little time, then you can come over and look up my app and website, where I have a lot of courses waiting for you. I have a lot of stories waiting for you, and I tell you my personal story, which actually really aggravates you, which actually energizes you to move ahead, as I was a pretty much average student. I'm sure you people must be doing much better than me, but then you really have to work hard as nobody else in the room, right? And then you reach higher, you become good, and then magnificent, and then tomorrow you shine as a star, right? Which actually guides and gives light to different people, right? And that is what I'm trying to do at this time. So now, children, let us look up what the sum is. Here we have an inequality which is to be proved. So the first thing that we're going to do is we will now first write what actually we have to prove, and here we have to prove that we have some 2n plus 7, and it has to be shown that it is less than n plus 3 whole raised to the power 2. Now this is an inequality, and as we have to prove this, that means if you keep any value of the variable, this should always come out to be true. Or in other words, we can say that this is an identity which is an inequation, right? Or in other words, you can say that this is an inequality identity. Okay, here do remember that when you choose n, it should be from the set of natural numbers only. Okay, now children, first step, remember, is P1. So when we go ahead with P1, we actually are going to prove this statement P for n, that is a variable, to be equal to 1. So here, as you don't have a few terms which have to be added together, you just will be substituting whatever the value of n is. As such, this is going to become equal to 2 times, or 1, to which 7 is to be added, and that is less than 1 plus 3 whole raised to the power 2. Right? So for the children, 2 ones is 2, to which 7 is to be added, and this becomes less than 1 plus 3 is 4 square. Or in other words, we have 9, which will actually become less than 16, and you know that this is true, right? And as this is true, therefore you can say that P1 is true. That means the statement P, when you kept the value of the variable to be 1, has come out to be true. Okay, so you heave a sigh of relief. The first step is done, right? Now comes the second step, about which I know that you're overjoyed, because you just have not do anything, but you just have to write what expression has been given to you is actually in itself true, right? So we will say that let PM be true. Do you remember the name of the step? It is the induction step, right? Okay, so now in this, what you do is, as we have our PM to be a statement where in place of n we'll be substituting m, so as such it is what? It is 2m plus 7, which has to be assumed to be always less than m plus 3 whole raised to the power 2, right? So this statement has to be now assumed to be true, so we will say that this is true. Now we come over to the third step, which is the step where we have to use this last step in order to prove that the statement P, where the value of the variable is m plus 1, is true. So now we have the proving step, where now we'll be talking about P of m plus 1 is to be proved true, right? Or in other words, you can even write proving Pm plus 1 to be true, right? So rather, this language is not proper, because this is implying that this has already been proved to be true, right? So you'll rather say that you talk about the statement Pm plus 1, and then what you require to do is you will try and prove this, right? So next, now what you are going to do is you will now be talking about the statement which is going to be Pm plus 1. That is, in place of m children, we have to substitute m plus 1. So if you look up the left hand side of the above step, we have 2 times of m plus 1, right? And to that 7 is to be added, and now that is less than, in place of m we have m plus 1. As such, this will become m plus 1, to which 3 is to be added, and then we have a whole square of this. Right now, for the children, in the next step, what you're going to do is, when you multiply this 2 within, this is then going to become equal to 2m, to which 2 is to be added, and further to it is to be added 7. Now this is less than m plus 1 plus 3, that is m plus 4 whole square. Now in the next step, what you do is you can now simplify this to be 2m plus 9, which is the left hand side, adding up the like terms, and on the right hand side in the inequality, what you have is, you now have here the whole square of m plus 4, which can now be written as m square plus the 2ab term, which is 8m plus 16, right? So this is an equation, or rather an inequation, which you have to prove, right? The above inequation that we had, we can mark it to be 1, and we know that that is true. As such, now we're going to use it, so that using it we can prove Pm plus 1. Okay, so further you'll be saying, using Pm, or in other words, if we talk about equation number 1, right, proving Pm plus 1. Now further here, what we do is we now talk about bringing in, which is already true, that is 2m plus 7, right? And from that is subtracted m plus 3 whole square, and we expand this and try and understand what actually this is. So this is 2m plus 7, which is actually less than m square plus the 2ab term, which is 6m, right, and plus 9. Okay, so this we know as true, right? Now children, if you look up in what we have to prove, there is one thing which is happening, that is, we have, except 2m plus 7, 2 more which is getting added. So let's add this plus 2 on both sides of the inequation. Then obviously it will not make a difference, because this inequation is true. So if we add a positive number on both the sides of the inequality, it will still remain to be true, right? So that is why what we do here is we will now be adding 2 to both the sides, right? So you will say plus 2, right? And this is what has been done to the above step of the inequality. Now next children, we have here 2m plus 7, which will already be there, and to that is going to be added plus 2. Obviously, as this is less than the right hand side, so obviously you will write the right hand side, that is m square plus 6m plus 9, to which you will also add 2, because 2 is to be added to both the sides, so that both the sides still remain to be such that the inequality is true, right? We can't say that they'll be equal, right? So in an inequality, the basic premise is that the sign of the inequality should be conserved. This is the basic requirement of solving an inequality. To remember this. So anything that we do is actually remembering that what is the sign of the inequality with whatever expression of a variable that we are talking about, right? So here children, now we further solve this out. So this becomes equal to 2m plus 9, and on the right hand side this becomes equal to 2m square plus we have 6m and plus 11, right? Now if say we talk about what we already had, right, so we had m square plus 8m plus 16, right, which has to be shown to be greater than 2m plus 9, right? So as we have this to be m square plus 6m plus 11, right? So as such, what we can do is we can now write this to be in the terms of what we require, right? And as such, we will bring it to prove 2m plus 9 here. From where are we bringing this? We are actually bringing this from the step which is pm plus 1. What is it that has to be proved, right? So from 2 we know this, that if we talk about 2m plus 9, right, that is to be greater than, that is to be less than m square plus 8m plus 16, right? So we have to prove this, and by which inequation? By inequation number 2, right? When you keep writing these numbers, when you keep changing the color of the ink, when you're writing a heading, formula, etc., the teacher is perfectly clear about what you're doing, and as such, very easily the teacher gives you full marks, right? Okay, so next, now on the left hand side there is not going to be any change as we have 2m plus 9, but on the right hand side we can make a few changes, as here we have m square plus 8m, and we just required 6m, so 2m is more, so we have m square plus 6m, to which 2m more can be added so that it becomes this, that is 8m. Now further here we require 11, but we have 16, so as such we're going to write plus 11, to which we add 5 to make it 16, right? Just try and remember that what are we trying to do here? We are trying to prove that 2m plus 9 is less than m square plus 8m plus 16. That is the statement which is pm plus 1. Now in order to do it, first we looked up what pm was, and as it is true, so obviously we can expand it, and even then this will stand to be true. So what we did was we took up pm, we expanded it, and then we had a clear idea about this, that it is true. Now since you find that in pm plus 1, when you add 2 more, right, you will get 2m plus 9. As such, 2 was added to both the sides of the inequality which is already true, that is the inequality number 1. We get this. Now we bring in what we have to prove, that is pm plus 1, which is 2m plus 9 to be less than m square plus 8m plus 16, and we write that down, and that is how? That is by inequality number 2. Now children, after this what we do is we get to see here on the left hand side we can write 2m plus 9. However, if we talk about the right hand side, it is going to become equal to m square, to which you will add 6m, right, to which you will add 11m, right, and if to it you are to complete the right hand side of this inequality, you further have to add 2m plus 5, right, and that you can put in a bracket. Now as you know that if you talk about 2m plus 9, right, that is to be greater than m square plus 8m plus 16, right? And here what you've shown is if you talk about just adding 2 more, that is to 2m plus 7, if you add 2 more, then what's going to happen is you will get here m square plus 6m plus 11, right, to which 2m more requires to be added and 5 more requires to be added. So here you can even say that if you talk about the change of pm by just adding 2, then obviously this statement is also true, like pm is true, thus by just adding 2 to both the sides of the inequality, this also is going to be true, right? So as you have m square plus 6m plus 11, right, which is greater than 2m plus 9, and now further to it, if you are to add 2m plus 5 more, right, where if you talk about m, it is an element of natural numbers, so obviously on the right hand side you have a further larger number, and therefore it's going to be true. Thus you can say that therefore pm plus 1 is true. I'll just quickly give you an anomaly in numbers, and then you'll be able to understand this with more clarity. Now children, if say we talk about a number 4 which is greater than 1, right, now if we add 2 to both the sides of this inequality, then on the left hand side we will get 4 plus 2, and on the right hand side we will get 1 plus 2. Now 4 plus 2 is 6, which is going to be greater than 1 plus 2, which is 3. As such, 6 is again which is greater than 3. So initially if you had a correct inequality, if you add a positive number to both the sides of the inequality, you will find that you will again get a true inequality. And that is what we've done here. We've added 2 to an existing true inequality, and when we added that, we found that what we get is also going to be an inequality which will be true, because plus 2 is a positive number. It will increase both the sides. As such, everything is fair. Just like I have shown you in this analogy with numbers. Now next, we now pick up PM, which was the true statement, and we've added 2 to both the sides, so we have this to be true. Now, as in what is in PM plus 1, we have 2m plus 9, which is less than m squared plus 8m plus 16. As such, we find that plus 2m is more, and except that plus 5 is also more. As such, we can say that 2m plus 9 will be now less than m squared plus 6m plus 6m plus 11, which in itself is true, right? But even then, there is another bigger number which is on the right hand side, which is a positive number. So obviously the right hand side is further going to be larger. For that matter, let us try and understand this. If you talk about 9, which is greater than say 7, so if on the side of 9 which is greater, if we add say 3 more just on the side of 9 due to some reason, right, we will again find that this as plus 3 is a positive number, so the left hand side will still be larger, or in other words, we will get 12, which is again going to be greater than 7, right? So if one side is larger than the other side, and in the larger side, if you add a number, then it's going to become further large, and as such, it will still remain to be true. And therefore, we can say that PM plus 1, right, is a statement which is true. Then remember, we've got to write that quintessential statement. You will say that since for every n comma m comma m plus 1, we'll club it all together, are element of natural numbers. Therefore, p m plus 1 being true, PM will also be true, right? And for every n to be an element of natural numbers, Pn is always true, right? So what we said here was, first we talked about n to be from the set of natural numbers, m, which was brought in between for the induction step, is also to be from the set of natural numbers. Now if we add 1 to it, again that is also going to be from the set of natural numbers. So as all of these are from the set of natural numbers, so if you talk about the statement p, where in place of n you keep m plus 1, right, if it is true as we've just shown it, then obviously you will have not pm but pn, which is what you had to actually prove, right, will also be always true, because if you talk about n, it is a value from the set of natural numbers, and m plus 1 also will be a number from the set of natural numbers. So as such, from the set of natural numbers, this statement p will always remain to be true. Now children, this was a little crooked sum, so I'm sure all of you people are waiting with your problems to be solved during the second explanation. So again, hold your pen down, keep your writing material down, and let us quickly concentrate and try and understand this sum once more, so that if there were certain places at which there are lapses, all of that will get perfectly cleared. So again, everybody sitting on a table and chair, not on a couch, because gradually what happens is you slide your hand and sleep and then doze off and then you're gone. Once when you're gone, that means you've slept, that means you're half dead and you won't be able to achieve the target. So make sure that you sleep at the proper time, you study at the proper time, at the proper place. That is a table and chair in which even I am seated. And I can tell you, I have derived a lot of advantage by sitting on a table and chair. I have been able to cut out a lot of my laziness. Moreover, when I get a little time, then I'll also tell you about sleep, and I can tell you this is going to make a marvelous change in your life as it has done to me. Okay, now getting back to the sum, make sure also that there's no disturbance, right? So you don't have any person around you, you don't have any of the gadgets around you which is disturbing, and you are sitting at a place which is quiet, so that everything which I'm saying can be accessed, understood, and also assimilated for a longer duration of time. So children, the question is 2n plus 7 is to be proved to be less than n plus 3 whole square, where n is from the set of natural numbers. This capital N actually represents that this is the set of natural numbers, numbers like 1, 2, 3 and so on up to infinity, which are also known as the counting numbers, right? So first we come over to the first step, which is P1. That means we try and check the statement P when the value of n is 1. So here, as we don't have any series, we just have to keep in place of n 1. So on the left hand side we will get 2 times of 1 plus 7, which will become 9, and on the right hand side we'll get 1 plus 3, which is 4, and its square is 16. So we find that 9 is indeed lesser than 16, and thus we can say that P1 is true. Simple, right? Okay, the next step is further simple. You just have to assume that Pm be true, right? And thus the statement that you've been given with n just has to be written in such a way so that in place of n you write m. So you'll have 2m plus 7, which is less than m plus 3 whole square, and you've got to consider this to be true. Remember, this is the induction step. Now after this we have the proving step, where we have to prove the statement P, where in place of n you have m plus 1, right? Now in order to prove it, first what we do is first we write what the statement is going to become if we replace m by m plus 1. So it will become 2 times of in place of m plus 1 plus 7. So this becomes 2m plus 2 plus 7, that is 2m plus 9. And on the right hand side we will then have m plus 1 in place of m, right? And to that 3 is added, and then we have a whole square of it, so this becomes equal to m plus 4 whole square. Now for the children, next what we do is we expand the right hand side now to be able to get a clearer picture. So we have a square plus 2ab plus b square. That's why we have m square plus 8m plus 16, right? Now we come over to that statement and inequality which is already true, that is 2m plus 7, which is less than m plus 3 whole square, right? So on the right hand side, children, we now expand again this binomial, so it will become m square plus 6m plus 9, right? And this is greater than 2m plus 7. Now if you talk about pm plus 1, then we find that on the left hand side actually 2 is more from what it was in PM. So let's try this out, probably this will work out. So that's why we will be adding 2 on both the sides to quickly try and see what the change is going to be. So what we do is when we add 2 to both the sides, we will get on the left hand side 2m plus 7 plus 2, that is 2m plus 9. And on the right hand side we will have m square plus 6m plus 9, to which when 2 is added it will become 11, as 9 and 2 are like terms, right? Now as PM was true, to which when you added 2 it should still remain to be an inequality which is true, and as such we'll have this statement to be true. Now after this, next what we do is if we talk about 2m plus 9, right, in accordance with what we have to prove, that is pm plus 1, we have it to be less than m square plus 8m plus 16. So here we keep this in purview and try and prove this, right? This is obviously by the second inequality. Now children, we are reminded of an inequality which is already true, that is 2m plus 9 is less than m square plus 6m, right? To which if you add 2m, then you will get to 8m plus 11, right? To which if you add 5, then you will get 16, right? So as such, if you talk about m square plus 6m plus 11, right, then we already have it to be a number which is greater than 2m plus 9, right? That's why we will keep it in a special bracket, and we will say that from here to here is already true, right? We already have looked it up by adding 2 to both the sides. So if we have this to be true, that is 2m plus 9 in itself is going to be lesser than m square plus 6m plus 11. So if a further positive number is going to be added to this, so obviously the right hand side will become further large, right? So as such, m being from the set of natural numbers, it cannot have a negative number. So 2 times of m plus 5 will become a positive natural number, which when added to the right hand side will become further greater than 2m plus 9, and therefore pm plus 1 will remain to be true for all the natural number values for n, m and m plus 1. So here we'll now recapitulate this in terms of a very important statement that you should be writing at the end of every sum on Principle of Mathematical Induction. That is, for every, right, this stands for every n, m and m plus 1 to be an element of natural numbers, right, therefore pm plus 1 being true, pn will also be true, right, because pm plus 1 obviously has been proved to be true. Now if you talk about pn, as n and m plus 1 both are from the set of natural numbers, so pn also for sure is going to be true, right, where n is an element of natural numbers, pn always is going to be true, right, is always, I've forgotten to write true, I don't know why, but obviously if you don't write true, how will we get to know that this is true, right? So that's why we have to write this, that this actually is always true, right? So this is the end of the sum in inequality. I'm sure you people must have got a lot of insights. Do write that in comments so that I can read it. Be happy that you've been all through the lecture and you'll be able to understand all of these. Make sure this is a task that you have to do, right? So after you've given such a lot of time, try and understand how the principle of mathematical induction works when we have inequalities. Now I'm sure you would like to study more of this type, so make sure you fill up a form which is there in my bio, right, a Google form link, which if you fill, then you'll get me on the other side. I'll catch you up live and I'll help you out. Moreover, there are also free gifts for you, like there'll be an email series, right, which will help you out in a topic of your choice, right? So I have a lot of resources to share with you, and I really want you to shine and shimmer in this class in mathematics as well as in life and get employed in a very good place, or probably provide employment. Even then you'll be earning good money, right? So all of this can accord a lot of happiness, not just to you but also to me, because you're part of my community, you're part of my family who's just trying to understand certain concepts, right, with the help of me trying to tell it to you and you trying to sit and understand it, right? So let's make this community a big success for our society and help out the world in becoming a better place. So that is why I have this tagline, join, joy, journey, right? So this is a journey where you'll be all through filled with joy, but the only thing that you're going to do is join it. So do join it by filling up the form. You'll get me on the other side, speaking live to you, checking out what your problem is and making sure that you win as soon as possible. So bye children, practice this, and bye for now.